Welcome to Rubber Duck Engineering. Tonight, we're going to play with implementing a decompiler for an Ethereum virtual machine compiled binary in Rust. Hello, Dr. Barth.
Hi, Eric. We got some advice over Twitter about how to improve our show, and they said in the first 15 seconds, you should explain what's going to happen in the episode. So we were trying it out.
We'll see. Oh, so how are you? How's the pizza? We can start with that.
Oh, we had pizza yesterday. So it takes a few days because you got to make the starter, and then you got to put the dough and have it slow rise in the fridge. And at each step, we forgot that we were supposed to be doing this. So we made this, instead of making the starter at night, we made it in the morning of the next day. And then the day after that, when you're supposed to make the dough, we just forgot to make the dough. And so instead of having the 2-day rise in the fridge, it only had a 1-day rise in the fridge. So we took it out and put it on the counter so it could warm up faster and rise. And so the pizza was a little bubbly, but it was still tasted good.
I have been making sourdough now for like a year because I was part of the fad. And I've made hundreds, probably 200 plus loaves at this point. But I have enough now that I can recover from most of my mistakes, which I feel like is a key phase in understanding.
Well, we could have recovered from this mistake just by rescheduling and saying, okay, we're going to wait another day and do the pizza the day after. But no.
So the Twitter did not tell us that we needed to jump to the code machine or not talk about sourdough. But shall we jump to the code machine?
Let's do it. So where were we? So we had just gotten a basic loop where we had read in the file, and we were just sort of starting to parse the instruction stream. And I think right at the end of the last episode, we used amazing vertical editing technology to make a bunch of instruction constants. But then we decided that wasn't really the thing to do. We want to make instruction objects, where each instruction object tells a little bit about the instruction so that we can then use the object in the disassembly machinery instead of having to hard code every instruction in the disassembly loop.
Exactly.
I nailed it. Did it.
Yeah, so we could show you. Oh, sorry, I've been doing a bunch of. So it's funny. I actually hacked a bunch of this on a separate machine over the weekend, but then I threw it all away because none of it was worth keeping. But this is where we had gotten to. So we have several things that are running in our little example program. One is that we just go look at the main loop here. So we read in this file that we compiled with our local Solidity compiler. We then try and disassemble it. That's what this is, right? Where we're printing out each thing. It's like, this is a push one. And then we dump it. What'd you say?
Yeah, we currently recognize 2 instructions, the add and the push one instruction.
Yeah. We're pretty sophisticated at this point. So here's our little recognize loop, right? Which we'll completely revamp when we actually make this a valid decompiler. And then we dump the contents because these .bin files, or I think these .bin files are actually a little weird because they're text. They're not actually binary. They're text hex. And then we run our little playground, I think.
I see. We attempt to execute it.
Yeah. Well, this isn't actually executing what we wrote right in. This is the playground that we had before.
Oh, I see.
Playground.
We built a little of the executor as well.
Yeah.
Got it.
So we mostly played, but I think where we can get tonight is making this thing real.
Okay.
I think that's a reasonable goal where we can identify which instructions these are. I did a little bit of reading over this weekend because, again, I was sitting down to try and do this, and it turns out only the push instructions are in line.
So everything else is just a single byte instruction.
Everything else is a single byte instruction. It's all the instruction stream is all U8, okay. And the push ones, it's like push one steals a single byte off the instruction stream.
I see. And then there's push 2 and 4 and 8 and 16 or whatever.
So we do have a friend in chat. Giffy says, please talk about the Fuchsia release. So we are interested in talking about Fuchsia on this, but we need to wait a little bit. Let that develop. It's not our story to tell here. So I think that'll be fun, but that's a future episode. And yeah, so we're going to do the instruction stream. So I think we can make this real. I think this is a doable thing. And then maybe if we make that, then we'll start actually making our executor real.
Mhm.
So the first step to that is, as you were just describing, these can't just be U8s.
Right. Because we want to have a little bit more information in the struct, right? We want to have the op code and at least a string about what.
Correct.
The name, yeah.
And so I started trying to do this on my own, and then I ran into, I don't Rust well enough. I still need my Rust training wheels.
Okay. I mean, should we just try it and see how far we get?
Yeah, so I think what I did this weekend was basically just did struct instruction, and then it was like op U8.
Yep.
Is that right?
Yep.
It doesn't like me. Oh, it probably doesn't like that this is the thing.
Yeah, optimate, and then you want the name, right? So let's do name as stir.
Sure. Well, I was even trying to make that first one compile, and where I got stumped was I couldn't figure out, like, this was supposed to be like op here or something like that. I think I did get this part to work, and then maybe I just got bored and went on to the next.
So that's good, but we just want to put the name in, yeah.
I don't know. Does Rust care if it's?
It wants double quotes.
It wants double quotes. Interesting. Dart squeals at you if you use double quotes.
So did you see what I did here with the this? Do you know what that is yet?
Well,
Okay.
I know this thing is the like anonymous scope. No,
That's a lifetime.
That's a lifetime.
So this ampersand means I'm going to borrow this value. So it's like a pointer.
Oh yeah, okay. This is lifetime static. Yeah.
Yeah. So this means. So then the question is, well, when is that thing going to go away? And so the lifetime tells you, and static means it's going to live forever.
And this one is like an anonymous scope, which is like.
Yeah. So you often get in the cases where you'll like receive something that you've borrowed, and you're going to give back something else that has a lifetime that's related to what you've borrowed. And so you'll often use something like a, which is a variable, and then you can refer to that elsewhere. And then sometimes you get in situations where it doesn't really matter. It's just some lifetime. And so you can use an anonymous lifetime.
Well, yeah, I think the anonymous one, I remember reading about these lifetimes. And it was like, be smart. And it was like, and then there's one that's like the parents or something.
Yeah, a lot of them are sort of implied. Like if you take I don't know what all the rules are, but like if you take a reference to self and you return a reference, then I think the compiler thinks that the reference you return must have had the same lifetime as self or something.
Okay. Okay, so this still isn't quite happy.
Okay, what is it not like?
Struct literal body without path. What does path mean?
Oh, so you didn't say what you wanted. So okay, so this instruction here, it says the type of this argument, this constant is an instruction.
Yeah.
But you didn't say what thing you wanted to construct. So this says now I want to construct a.
So we have to type instruction twice.
Yeah, I don't know why, but for like we can try to take it out. But for some reason, the const, if this was just like let, then it would be happy and infer the type. But for some reason, const really wants you to
missing type for const item. That's weird.
Yeah, I don't know why const is like makes you do this repeating, but like let doesn't make you do that.
All right. Maybe we should look at that. Or you think that that's just how it is?
I think that's just how it is. I don't fully understand. Okay, so I'm gonna try our crazy vertical editing technology to do all these at once.
Okay. Let's see if I can get a rubber duck window. Sure. Whoa, so much vertical.
What did we decide? It was op, and then it was name, and then it was the name.
Oh my goodness! How did you get the name?
I copied it
out of.
I'll do it. If you scroll down, I need to do this other block. Oops, it just auto formatted. But let's. Yeah, if you scroll down to below those, we'll do the other block.
Because you moved by word or something like that.
Yeah. Okay, so first I need to establish my vertical selection. So on my Mac, it's what I'm actually using
like
a Windows keyboard.
Shift down or something.
Something. I use a Windows keyboard on my Mac, so I have no idea what anything is. So anyway, so now if I use it, you can't see, but I actually have a vertical selection that extends all the way down below here. So now what I do is I use Control Shift Right, which is word advance. And because I did word advance, it word advance on all the different lines.
Yep.
Then I'm going to do Command C, so I'm going to copy.
Yep.
So now I have a vertical thing in my copy buffer. Then I'm just going to go through, and I'm also going to word advance to get to the right place here.
Yep.
I can type instruction.
Yeah, the word advance is really key here.
Yeah, sometimes you want word advance, and sometimes you want character advance, and you have to decide what it is. And then oftentimes, if you like now, I'm sort of diagonal. So if you want to get back to straight, you can press the home key, which will take you back to the start of the line on all the lines.
Okay.
Or you can press the end key to go to the end.
Makes sense. Yeah, those movement keys are really key.
I learned this because I use VI a lot, and VI is all about the fancy movement keys. It turns out they exist basically in every editor. You just have to learn the combinations for them. So I'm going to say save. Boom.
I remember when I used to work a little bit on AppKit. I was never on the AppKit team, but I was adjacent and sometimes, would hack on it a little bit. And we would like fix bugs in the Emacs bindings because that was like Mac has like Emacs bindings all built in, or did at the time. I don't know if it still does.
So I think we've actually messed this up.
Why?
Well, I don't know if we really want we somehow need a way to look up instructions by opcode.
We need an array of these.
We need an array of these. And do you want to do that now, or do you want to do the push ones?
I mean, there's a question of at some level, this should all be generated code. I don't know if Rust does that, or maybe this is a macro.
Yeah, but we can go into macro, but I don't. Let's try to not do macro for now.
They were terrible enough in C++.
They're actually amazingly powerful in Rust, but I think it's a little. We can go into that rabbit hole, but
maybe not tonight.
Yeah.
This is where I got stuck. I didn't figure out how to detangle this. I'm sure I could have, but yeah, I don't think we should do push yet because I think.
Okay, should we make an array that has all these things in it?
Sure.
I'm not entirely sure how to do it anymore. If they were all on one line, I could do it with amazing vertical editing. We've lost that.
They're all. You could do it with greps, with search. No.
Oh. We can also just go back to our source. We had a remember we had some spreadsheet that had all these things in it.
Yep, I think I might have it open here. This thing.
Yeah.
So I think here I can do some vertical editing. Now we can do an array of these. I don't know how to do this, but const instructions. Then let's see if I can remember the vertical selection keys. Not quite. Nope. There we go.
Oh, you're doing it with the mouse. How bold. I always do it with the...
Oh, I don't know these fancinesses.
I just do it with the arrow keys. Okay. All right, I made the stop line up for you.
Okay, and then this is op. Yep. And then you do end. Oh, such power.
Boom. And then that's good. You want to put... So at the beginning, we want like a vec bang. Yeah, we don't actually have push one either, so we should comment out that one too.
I figured we want push one.
Yeah.
A vec bang? What's the bang?
It's a macro. It basically makes you a vector out of the arguments. Oh, it wants a type.
These are...
It's going to be vec.
These are instruction. Vec instruction.
Equals.
When is it equals and when is it colon?
Basically, if you have if you're in a curly brace, it's like a JSON object and it's colon. Whereas if it's a assignment statement, then it's a. But so like it's like if it's a name parameter. Yeah, so this is like an assignment statement. This is a type. This colon and this colon are quite different. this colon says I'm attaching a type to this name.
Mhm.
This colon is like I'm calling this named argument on this constructor.
I see. So theoretically, if this was a let statement, you would just remove this, right?
Correct.
See, but these things require types to attach them for whatever reason. All right, so Mitch badge types. Oh, interesting.
So let's comment out the playground thing because we're gonna have to come back to that. Let's just try to focus on that.
I just don't think it's actually that useful anymore. Okay. All right, so this is the thing to.
That's part of our executor. We want to comment that out for now. We don't really want to execute things.
Oh, okay.
Sure. We'll come back to it.
Mismatch types.
Right. So we need. I think we should load our instructions into a hash table and look them up instead of with match with the.
Well, the only ones that need special handling are the push ones.
Oh, but we can put that on our instruction. Like our instruction object can know what its arguments are. Like we can say argument is, 1 or 2 or 3.
We can. I don't know that we'll need to, but sure, that's fine.
So I think we should look up how to efficiently load our array into a hash map.
Okay. Let's see. Load array into hash Rust. I'll get a map from the list in a functional way. Iterator collect. What'd you say?
Right. So yeah, we want to map it into tuples and then collect it. Okay, that makes sense. So we can say, I'm typing in the other window if you want to go over there.
Mm-hmm.
Hash map something to something equals instructions map. So we'll get our op, and then we want to produce from that a tuple. That was the op. So like the op of the instruction mapped to the instruction.
Mm-hmm.
And we want to collect it.
Okay, it seems reasonable. Why's the map?
Oh, we need to make it into an iter. I think we need to iter it in order to map it.
And
Too many dots.
why hash map? What is this? What is hash map from?
Oh, SCD collections.
I need to learn how to home here, not home.
Why don't I move all the ops into their own file?
That sounds like a good idea. Use STD collections. Semicolon here. Maybe I need this to be hash map. Okay, cannot find instructions in scope, so we have to open that file somehow.
Yes, so let me show you how to do that.
So we have a namespace.
The first thing we need to declare that it exists. So we say mod instructions. It's like a child of our module. It's like a child module.
Okay.
And then we probably just want to use it, like bring all of its names into scope.
Okay.
Like that.
What does the crate mean? That's like our self-reference.
So crate is like STD is like the standard library. Crate is like our program that we're working on.
Okay. It does not like us.
Oh, okay.
Maybe we could try. Constant instructions is private. That's our problem in life. We have to like say public.
Just put a pub in front of it. Yeah. Just pub.
Pub.
Yep. Okay.
Okay. Sounds good. Sorry about the noise. There's been like helicopters or something flying around, and they managed to make my house shake.
Oh wow. Okay, so now we have this. So now we need to go look this up. So we need to say like let instruction equals get op. Then it might fail. So I think we should put this whole thing into a function that can return an error, because there are going to be many scenarios where we want to be able to return an error.
Okay.
So let's move this into a function called like disassemble.
Well, I think that's fine. That's fine. The disassembly is also like a separate thing. Like in the final VM, you don't normally use the disassemble mode. Right. This is sort of it's like a step along our journey here.
Yes. Oh, yeah. So what did this get? I'm just going to take all of this in here. Remember we had this funny closure that we made that we need to fix at some point?
A funny closure. I don't remember. I'm a little lost as to where we are here. Oh, I see. You pulled all this in. Oh, this thing, the take closure? Yeah, the take closure needs to get moved onto an input stream or something, but we'll deal with that.
We'll get it sorted.
I really need to just go through some Rust tutorials. I just need to spend some hours on Rust.
So there's some sort of error here.
Oh, I can bring up the error display. Mismatch types. Expected enum result found.
Did we get rid of our VM error? No, we still have VM error. I don't really understand what...
Implicitly returns as its body has no tail or return expression.
You say, okay. There's something syntactic, like it's not auto formatting.
Okay, well that may be part of it. Mismatch types. Yeah, I think we have a syntactic error here. We haven't dug ourselves out of this yet. Okay. What's this one from? Okay. Does this have enough? Return body has no tail. Yeah. Mismatch type. Found expected result. This is where in other languages I just start deleting code until I can get it to be happy.
That makes sense. Or just commenting things out.
Yeah, so like there. Now it needs to format correctly. Whoops.
Okay.
Okay, let's start adding things back.
Okay.
Add. No. Okay. This thing. Yep. Okay. And take. Is this take? While? Oh, I see. This is the while loop. So this is where it should fall over.
Oh, this match here. Look, this match doesn't have enough curly braces. Let's add another curly. There we go.
There we go. Okay. Calls and constants are limited to constant functions. What's a Oh, vec here. Allocations are not allowed in constants. Okay, show me where this is called from. Somebody suggested that there was a different Rust analyzer that was better. I briefly looked at somebody on one of our video comments.
Oh, really?
It was like the Rust analyzer extension, but it had so many fewer installs, I was a little worried. Temporary value dropped while borrowed. Oh, we had this before. Where like we had to pull iter into a...
Oh, like a...
Yeah, exactly. I don't fully understand why. Like I feel like temporary value drop while borrowed.
Which value is that?
I mean, this is our second error, which would suggest that this may not be our actual error. Well, it's our first error in this file. Temporary value is freed at the end of the statement. 102.35. Oh, the iter is? Borrow is later used here. So do we have to like, how do we?
I wonder if the problem is that this like constant vector is not legit. Let's just try making that a local instead of.
Okay, unresolved import. Oh, I see. I see, like vec might not be.
Yeah,
well, these were not const. It was sad about. Cannot find. Oh, those all have to be public, which they need to be anyways.
You want to go make them public?
I'm on it. I'm going to use fancy search replace. Okay, there you go. We seem happier now.
Okay.
So what's our theory as to why instructions are not?
Oh, well, vec like allocates something on the heap, right? Like a vector is it's like an STD vector, and Rust may not allow you to make that a constant. I'm not sure if you can have a. There's a crate called lazy that we use that will allow you to lazily instantiate things in the global scope. But
specify the length.
Oh, okay. We can do that.
The length is the proper way. There's no boxing of values at all. Slightly less efficient due to pointer indirection.
We can specify the length. Should we do that? It's just going to be some number, right? Like.
I see. It's just like this.
Okay, we can try that. Let's try moving this back and specify the length.
All right, sure. I mean, I feel like that's the right.
Yeah, it should be a global constant, right? These are all the virtual machine instructions.
These also need to be public, so that's good. All right, so you're not doing a vec, but rather.
Right, so we decided this had to be a pipe instruction. And then,
yeah, whatever it is, 35 or
35.
I pulled that out of my rear. Let's see. Does my selection tell me how long it is? I'll have to do line 284 to 353 minus 284, 69.
But 3 of them are focus.
3, so 66.
Okay. And this needs to be a semicolon.
Okay, great. It's telling us now. Telling us 67. Great.
I see. Okay. Good times.
Expected value found modulo instructions instead. Okay, good. Cannot find value bad op.
All that was to get to this point where we could write this code to say, if you couldn't find the op in the hash code, then return it as an error.
Okay. Unused. Okay, great.
So now we can print out the op, right?
Well, except this should be
op. And
I don't know what the format for that is.
So we could try running it now. So it's going to screw up the push instruction.
Error, bad op. We also want it to print which one it tried, if it's going to do that.
Right, so we can just return the op. Make bad op take an was an I8, a U8.
Okay. Oh, this is totally. You're totally going to hit a bad op like right away because you're not handling push.
Oh, push. Okay, so let's add push.
Well, so we need to talk about how we're handling because the second is gonna be a bad op too.
So what I think we should do is, well, we could special case them in the loop, or we could teach the instruction about like how many more to consume.
At some point, we want to, like in our disassembler, we want to. So they were begin with the end in mind, right? So we want to print something like this, right? Where we say what the arg is.
Mm-hmm. I guess what I'm saying is because the instruction set is so regular, and the only thing that we need to do is push, we can just say, if the instruction told us how many more bytes to consume, then we could just consume them and realize that it's going to be a single numerical argument to the instruction.
I see, but where do we store that consumed thing? So the consumes are a variable length, right? So push 1 consumes 1 byte, push 2 consumes 2 bytes.
Mm-hmm. So concretely, just for the disassembler, I was going to add a field to instruction that was like argument length.
Great. Okay.
Should we try that?
Sure. And then can we write let's assume that field exists. Let's write the code after that. That's what my brain is missing.
Okay. So we're going to discard this thing. And we're going to say let arg equals instruction dot whatever it's going to be, like arg bang equals 0, then arg equals take some take else none. Oh, we just do this.
Yep, exactly. We just have different print statements.
Yeah.
Okay, so that's going to work for push 1.
I think that we need to tech up our take technology, because right now take always gives you 1 byte, whereas we're going to want a thing that can consume, like an input manager that says, okay, take 1 byte, take 2 bytes, take 4 bytes.
Okay, and then how is it going to have a variable return type?
Well, each of those different operations will have a different return type. So it'll be like an object called input manager, and you'll say, take.
Oh, sure. And then we have like a switch here based on the like arg.
Yeah. So like right. So then we'd have a right. So it becomes match instruction arg.
Yep.
And if the instruction type is none, then we'll do this. Otherwise, if it's like arg q8, we'll say like input. You love to do this fantasy code. It's really uncomfortable for me, but I'm enjoying trying it.
I'm just trying to push on what this, because I have no sense in Rust. I'm trying to push on what this code looks like, just so we don't end up like doing all the work to plumb the thing and then decide the plumbing is wrong.
Right. So then let's say we had arg u16.
Mm-hmm. I'm going to look real quick at what. It's like right here. No.
But if you really want to get fancy like this, the way you actually do this is. You're just saying what actual pushes exist?
I'm trying to remember what the. I just don't remember. Maybe it's this one. Yeah,
that's good.
I'm trying to remember, and it's like 60, I think. Yeah, int 8 and 16. Okay, so this is. Does Rust have all these types?
No, it caps out at 64. But
okay,
we'll eventually need a big int type that can handle such large things.
Okay.
But for now, we can just cap out at 64.
I think probably all we need is push 1, anyways, for our example.
Yeah.
For our go ahead.
Yeah, so I was just going to say that if we make arg into an enum, we can say let arg equals input manager dot take arg inst.arg.
Oh.
And then we can do this.
And let can vary type at runtime? But how does take arg have a variable return type?
I will show you that in 1 second. Then we can do this. Okay. So let's try to make this fantasy code work. I believe we can make this fantasy code work.
Great.
So if we go back to the instructions file at the top.
Mm-hmm.
We're going to get arg, which is void u8 u16, and then here's the trick.
Whoa!
The enums can now carry a value with them
because they're unions in Rust.
Right. And then the other thing is we're going to impl what is it? T display for arg.
Whoa. Okay. Yeah.
So we should look up what the idiom is for this, but this will let us define how it gets printed out.
Right here.
Yeah, drop that in the file.
Okay.
I'm gonna get rid of all these comments. Basically, we're going to match on self, and then we're gonna have all these cases.
Yeah.
For the void case,
you had used none before. Do you want void to have an explicit void?
I think a void is like none will get confusing with like option none.
Okay.
But it's going to play the same role as option none. This is how option works, right? Where there's like some and none.
Mm-hmm.
But here we're just using void and all these things.
Yep. This all makes sense.
So for void, I think we're just not going to do anything. Whereas for U8, we'll print out value. That make sense?
Mm-hmm. It's mad at us, but mismatched types result found.
Oh, what is a format result? I see. We're supposed to actually. So how do you return a? Just a. Should we just say like? Okay.
Okay. Cannot find input manager in the scope. Okay. Yeah. We haven't made one.
So let's add the arg to here. This is just going to be an arg.
Where are you?
I added it to the instruction struct.
Can it be optional? Default values exist?
Yeah, well, sort of. But I think you do it like this. Impl instruction, and you say there's a pub function called new, which takes an op u8.
Oh.
It gives you back an instruction. This thing does this. Name. And then you say fn new with arg. This is like what we were looking at in your one of the board game projects that you were doing.
Yeah.
This kind of thing.
Game constructor kind of thing. I see. So there aren't default values. I feel like there were default values in C++. C++ constructors, or am I misremembering?
There might be. I just may not be aware of how to use them.
Default value Rust. Default function arguments. Okay, Rust is not constructor. Struct field defaults. Oh, this works when instantiating. Totally works.
Oh, okay. Awesome. So
great. So this is needed. Right, so
Great.
we can just comment this out. Let's hold on to it just in case we end up needing it.
Okay.
And this has been equal to arg void. Is there something wrong here?
No. You probably don't need to say arg here. It knows that it's a void. Here, it knows the type.
It says b colon.
Well, for integers, you don't know like whether you wanted a 64-bit integer or a 32-bit
Sure.
integer. Oh,
It still wants it.
okay. Oops. Happy with it?
Expected. Let's see if this is just someone. Oh, this is something like. Sorry.
No.
Oh, this is just someone asking.
Oh, it was a dream.
It was a dream. It was a glorious dream.
Okay, I don't think it exists.
This is from 2016, but. All right. Yep. Default value struct field. There's an issue. It got closed. Closing in favor of other thing. Wow. I'm totally down the rat hole. All right, whatever. We should just implement it. There's an RFC.
They're working on it.
I
Just figured out.
for April 6th. Still working on it. Make a small one for default on enums, nothing else. Yeah, I don't think it is still in progress. I think your solution is fine. Oh man, you're totally on it already. Whoa, you lost all your op.
I do.
Oh, you could have done this with search replace, man.
I could have done this with search replace.
Hmm?
Oh, okay.
You only need to change it in one spot.
Do a search replace.
Yep. So you just search replace just this, right? I think you basically replace this with is that right?
Oh, you need a left parenthesis instead of a curly brace.
That.
Yep, that's the beginning. And then
Okay. Whoops, I need this thing.
2 files.
And oh, whoops.
Yeah, I'll go fix those. That's fine.
I can also just undo it, but yeah, it's fine.
That's cool.
And then we just need this thing.
Yep. Okay. And then you got to get rid of the op colon and the name colon because now they're positional arguments.
Oh, sorry. Okay. I didn't realize it was this crazy.
No, I mean, you're almost there.
Okay.
Yep.
I want case sensitive.
And you only want it in this one file. There you go.
Oops, no. I want to replace it with 0. We're a little into the crazy weeds here.
Okay.
This is what we did in the primitive times before we had multi-line selection. Okay. Does that work? What do we got?
Oh, it was a little bit too aggressive.
That's fine. It always is.
Really, there you go.
Okay. Expected keyword. Do we do it again here? Pub?
Yeah, I did it again. a little too powerful. Oh man, it did it over here too. I don't know if the search replace is really.
Yeah. I just thought we had to do it. You were on the right path, and I dissuaded you. Instructions arg doesn't implement.
That's okay. We just drag the bugs. That's fine.
Lifetime trait must be followed by plus. Lifetime and trait object.
Oh, this is
Missing field arg.
arg. Cool. I agree.
No variant or associated name, none.
Oh, it's void and none.
Mismatched delimiter. Yeah. Cannot find input manager. Okay.
Okay, should we add push and pop while we're here?
Where are we even?
Oh, we have push one. Let's add push one. So arg u8.
And this needs to be new with arg.
Oh, there's a flaw.
It cannot be a flaw.
We've confused arg value and arg type. So the thing we implemented was arg value. We also need an arg type.
Okay.
Because the arg type, we don't want to carry the concrete value with us.
Okay. Which is which?
Well, the instruction declaration will have the arg type. And when the input manager returns, it'll return an arg value.
Okay. We may have gotten a little too fancy here, but that's fine. Okay.
Okay, that's fun. Fancy.
So this is arg. The display is for the arg value.
Yeah. And those are arg. Yep.
Okay.
Okay, so now we need input manager.
Okay, and that's a new class that turns our take into a real person, real code.
Input manager. I don't know what it's going to hold yet, but we're going to new it up with something.
Yeah, it's going to take that string, and then you're going to disassemble from the input manager. But yeah.
So this code that we have here, this all feels like stuff that should go into the into here, right? These are our ops. Oh, so it has a vector. The vector of U8. Right. That has stuff like an index.
Okay, yeah, that makes sense.
Index is going to be a U size. That's like where we are.
Sure.
0. Let's just take that we had before, right? So take is going to be. It's going to get back an option of U8. So I'm going to say if.
Oh, this is the take before, yeah.
Index is less than.
It's right here. Can we just copy this, basically?
Oh, exactly this. Very good. Okay. This I is going to be self.index. Okay. Great. So now we need this and this.
Yep.
Cool. Let's take it. So now maybe we should take an input manager as an argument.
Ops need to be listed here somewhere. Why is it sad? Cannot find value ops. Do I need self dot?
Yeah, self dot.
You're explicit. Okay, cannot find I self dot. You were saying, sorry? Mismatch typed.
I made input take an input manager, or disassemble take an input manager.
Okay, that makes sense. And now disassemble. Whoa, I see this. Yep. Yep. You want manager. It's fine. I'll add A's for you.
Okay.
Okay. And then this thing is called input manager. Okay, take arg.
All right, we did all that, and now we're ready for take arg.
is the dramatic reveal.
Take arg, so it's going to take mutable self. It's going to take a type, which is an arg type, and it's going to give you back an arg, right?
Arg value, you mean?
Value, right. We need to match. Type is a reserve word, so it wouldn't let us do that. So now we need to match on the archetype.
Calls. Okay. Yep.
We just need to fill this out from our enum up here.
Was it calls and constant? Okay. These need to do colons after them, I assume. Oh, yeah.
Arrows or something. So void is going to give you back archetype void.
Arg value void, yeah.
Value void. U8 is going to give you back arg value U8 self.take. And then U16. Okay, I actually know how to do this.
Well, we can do it like math way, but we also could just.
No, there's a U16 bytes like native Indian, from native Indian bytes.
This would be so much easier if we were working from strings. Oh, no, it wouldn't. Never mind. Oh, yeah. It would, but.
It actually needs to return a result because we could fail to do this. Take okay.
Need to return okay here?
Yeah, error.
I see, because the bad op here is like we didn't have enough.
Yeah, we can make a new error type for it if you want.
Well, it's just bad op is going to need to be passed an op because we don't have one.
Oh, I see. Well, let's make a new type.
I can do that.
Bad arg.
Oh, or just end of stream or something like.
Oh,
yeah,
sure.
Let's do bad arg. From NE bytes, native NE bytes. Well, this is always big Indian or something, but yeah. But I guess once we've converted it to native Indian.
Well, yeah, it should be big Indian if it's big Indian.
I'd have to go look at the, but it says. Oh, too many tabs. Let's see. Memory storage opcodes. I swear I was reading this weekend. Overview.
Define an Indianness for its arguments, like it's gonna
big Indian VM. Stack-based big Indian VM. I don't know if that. I mean, that must presumably that means the encoding of the option as well.
U16. We'll actually be able to templatize this, right? That's why I'm doing it this way.
I see. Because then it'll be option T or whatever.
Yeah, and this is going to be whatever it's going to be U16 from big Indian bytes.
Is it actually big Indian bytes? It's going to be native Indian bytes, right? Because we're not reading it off the.
We did it byte by byte, right? We byte by byte took the ASCII representation and laid them out byte by byte.
Okay. Yes. Yes, you're right.
Is it,
Size.
something is wrong here.
Size of value type mismatch types.
Okay, what does it want?
Expected U82 found a borrower.
Okay. So I don't know how to call this with a slice then. So could we ask Google how to call this with a slice?
I love that it.
Yeah.
Using a byte order crate.
Okay. Do you want to add the byte order crate?
Sure. As of Rust, you can also use from inherent methods on integers.
Right. But so the argument is just, oh, you need to, wait, if you have a slice, you need to convert it into an array. Click on that. Yeah, scroll down. How do we do this?
Try into.
Okay. Do that. There's also just into.
I'm happy to add that crate.
I don't think we need it.
Try into.
Yeah, so try into is like a, it's a way of converting.
But you want try into, not into.
Oh, I see, try into.
No method name try into.
Oh, we need to import try into. Where does it come from? Try into?
Convert. Standard convert try into. Okay. It's a little crazy, but sure. Mismatch types.
Right, so now we need to map error.
We need an OK error or whatever, right?
Yeah, so in this case, it's already getting back our results. So we just want to map error, translate their error, which I don't care what it is, into...
map error is what I was missing this weekend.
So what did you call our argument here? Bad art?
Uh-huh.
And then you make a question mark that says, now return that.
Question mark could not return the error to standard option none error. Trait from VM error is not implemented for standard option none error.
Oh.
Is that because you're...
I think we just need to add the error trait.
Does this need to be VM option comma VM error here? Like, don't we do this other ways? VM error?
Oh, yeah, totally.
Cannot find error macro in the scope. Yes, if we just remove this, we might want it later, but mismatch types.
All right, so we need to just say or something.
Oh, this is the bad arg or whatever, right? Yeah. Okay, mismatch types. Yeah, okay. Mismatch types. This is not option, but rather result. I have some idea what's going on. Except this is not the result U8 VM error, sure. Method take exists for mutable reference.
Take U8. And we can get rid of these because we've already established what the error is going to be.
Okay. Mismatch types. Sum.
We would just say let op equals this. So we put the question mark here.
Okay. To carry the error.
Take arg.
Whoa. Calls and constants.
What?
We got into this thing again. Every once in a while it does this.
Oh, because these are constants. So it doesn't like our constructor call. Do they have to be constants? Can we just make them? When do we get to import the lazy struct, the lazy crate?
Okay, sure. What's the lazy static or lazy.
Lazy static.
This thing?
Yeah.
I don't know.
Maybe we don't want to do that. That's a sort of a bridge too far.
Why do I see? Because we're constructing them, so we're sad about that. So we could just be explicit about them. But all we were doing was saving ourselves some typing before.
We could try
There's
to.
no constant constructors in Rust.
Well, I'm just looking that up. There's currently no way of doing this. Yeah.
I mean, we don't actually need to have them like this anymore.
Right, we can just go back to just doing it, just declaring it, like using the declaration syntax. We can try doing it vertical editing style instead of search and replace style.
Go for it. We could do. We also could just throw them all in an array because we don't actually need to reference them one at a time anymore.
I see. I feel like we're
Right.
going to.
So you could vertical edit it your way to just delete all of those, delete all the front half, and then we slap them all in an array. I don't know if that's better or worse.
I think we're going to eventually want to reference them.
Okay.
Do you think? Maybe not.
This is like one of the things I learned in my last round of implementing some game and then making my own little DSL is that YAML actually is the way here.
Yeah, maybe we should be reading these things in from some config file.
Yeah, just reading them in from a config file because then you can restructure the code very easily. Because otherwise you have this problem where you're like actually editing data and the data should be really simple to like search, replace, and edit.
Yeah.
It's a little inelegant because then you have to like, you have that read-in step and you don't have like type checking inside your data file. But I should also note we're over time. So once we get I think we are so close to victory.
Yeah, just
unterminated double quote string. Where we got this? Whoa, hello. Oh,
yeah, a little worried to press save here because it's gonna like when it's in this form we can edit it very easily, but as soon as the auto formatter breaks it into multiple lines, then we're gonna have trouble.
Yeah, makes sense.
Do you want to put like a no format block around it?
Because you're worried it's gonna.
Yeah, I think there's some way of telling the Rust formatter not to format something. So before we save this, can you look up how to do that? Or...
Rust format skip.
Okay, so I think
skip
just
items.
Just do that to the whole file, right? So #bang. What was it? Rust format skip
Works on stable. Config adder Rust format skip works on stable. Okay. Yeah, because you're gonna want #bang or something to like. It doesn't like you. Cannot find attribute.
Oh, try that.
I think you might want this.
Oh, okay.
#bang.
Okay. Did you save it? It worked.
Missing field arg.
Okay. Did we forget the arg on something?
I just got a comma.
Oh.
What do you think? We're gonna? We are over time.
I think we're like 1 inch from victory.
I think we are too. As I manually edit these. Okay, cannot move out of inst.arg, which is behind a shareable reference.
We'll just make these things copyable.
Unused variable E. Okay, I can make that go away. Pattern binding void is named the same way.
You need the arg type.
You are just a vertical editing fiend here. In irrefutable while let pattern. What does irrefutable even mean? Note, warn irrefutable let patterns on by default. So the loop will never exit.
It's not really an error when you get the last op, right? Like the take op should convert this into a Right. So we need to do this. This really should return option. And then I forget how to convert a result into an option. It's just like
map do that.
Okay. We did it, team.
We did it?
I think so. I mean, if it compiles and it's written in Rust, then it must be correct.
Oh, Rust is such a trip. All right, let's see. What'd it do? Bad op, 96.
Okay. I feel like we should print as we go. Oh, we did print as we go.
What the heck's bad op 96? How do we even get to 96? Oh, I see. That's not printing as hex.
We'll just print out the op that we got right here. Oh, it's gonna give us 60. Oh, we didn't add push to our array.
Oh, where is our array?
Here we go.
Just did it. Oh, what do we do here?
Try it again. Good.
Oh,
it's the wrong length array now. It's 68. Boom.
28. 80. Yeah, because push 1 should consume it.
So push 1 didn't know that it has an arg. Oh, I see. We didn't give the proper arg type for push 1. Okay.
Viewers don't get to see you changing, but I believe you. Okay, here we go.
Run it again. I took out the XSX so you'll be able to see
Call value.
Yeah, it's good. But just run it again.
What is call value?
I feel like when we print out bad op, we should print it in hex.
Yeah, I don't know how to do that. Okay. Where is that?
It's probably just one of the things we haven't implemented yet. Like
oh, we haven't given it the trait or whatever, just like this, right? That this format display for what is it? We said 34. Call value.
No, that was the one before. What's the one after? The bad op is the one after that. So what's 128 in hex? Seems like that's going to be a very round number.
It's going to be 80. Yeah, 80.
So what is 80 in the bytecode?
Dupe. Oh, yeah. Okay. What does dupe even do? Clones the last value on the stack. What's dupe to? Clones the second to last value on the stack. What? What is that even for?
I think we should stop here, but
yeah, I agree. I think
we just have to add in all the instructions that we've skipped, right? Like all these dupe and push and swaps.
I think we did quite well. Came in a little late, but I think we did very well.
We're not quite there, but we just have to add in the extra instructions, and then I think it'll work.
Whew, that was a race. A race to a disassembler in 70 minutes in Rust. Really, the obstacle for me, and I feel like this makes it difficult for me to help speed us up as a team here, is that I just need to learn Rust. I need to spend some more time in the Rust saddle.
Yeah, you really need a friend to help learn Rust. It's hard to learn Rust just by reading the internet. Because you have some questions, you're like, and you're like, add more question marks.
And how do I find that on Google?
Search for question mark. Clearly,
I
right,
think
Eric,
it also would help to work in a larger code base.
that's true. Because they have examples you can copy from and say.
Yeah, exactly. You can go read. I mean, that's how I learned C++. Like, I had some C++ class as my first class in college, and I'd actually written a good chunk of C++ before I came to work. What was my third job at Apple on the Safari team. But that is when I really learned C++. So, anyways,
well, it was fun.
it was fun.
See you next week.
Yeah. Have a wonderful night, all.